Hi students, in this video we are going to discuss exercise 1.1 first and second question. So we'll discuss the first question now. Determine whether each of the following relations are reflexive, symmetric and transitive. So first of all, reflexive is whenever we have an element from the set A, then we should have A comma A form in the relation. If we have in this way, in this form, then we say that relation is a reflexive relation. Then symmetric relation, in a given relation, if we have A comma B belongs to that relation, then we should have B comma A should also be in the same relation. If we have in this way, then it is symmetric relation for all A comma B belongs to the set A. Then for transitive, if A comma B and B comma C belongs to R, then A comma C belongs to R. So this is what the basic concept about the relations. In this relation, they have given as x comma y such that 3x minus y equal to 0. We'll take that particular equation alone and we have a as set of all numbers from 1 to 14. So we'll be choosing y in such a way that it is a multiple of 3 as we should get the difference as 0. So that if x is 1, then y should be 3. If x is 2, then y should be 3 2s are 6, so y should be 6. If x is 3, 3 3s are 9, so y should be 9. And if x is 4, 3 4s are 12, so y should be 12. If we choose x as 5, 3 5s are 15, we don't have the number here. So till 14 only we have. So we cannot just proceed with the numbers. So finally the relation is 1 comma 3, 2 comma 6, 3 comma 9, 4 comma 12. So this is the relation we have found. I'll just write it here. So R is equal to 1 comma 3, 2 comma 6, 3 comma 9, 4 comma 12. So first for reflexive, we should have 1 comma 1 in there. We are picking 1 from the set A. We don't have 1 comma 1 in the relation, isn't it? So 1 comma 1 does not belongs to R. Therefore, R is not reflexive. Remember, in exam, you have to write the definition, then we have to write the answer for that particular thing. So R is not reflexive. Then for symmetric, if you take 2 comma 6 from R, here 2 comma 6 belongs to R, but we don't have 6 comma 2. So 6 comma 2 does not belongs to R. Therefore, R is not symmetric. Then transitive, we have to choose two pairs that holds true layer. If we take 1 comma 3, we'll take 1 comma 3 belongs to R. 3 comma 9 belongs to R. We should have 1 comma 9, isn't it? A and C. Do we have 1 comma 9 here? No. So, but 1 comma 9 does not belongs to R. Therefore, R is not transitive. So, this relation neither reflexive nor symmetric nor transitive. I hope it will be clear. We'll move on to the next question. If you want to note down, just pass the screen and note down. Question number 2, or sorry, subdivision 2. We have relation R in the set n of natural numbers defined as R is equal to x comma y such that y is equal to x plus y and x is less than 4. So list down the proper ordered pair. If we choose x as 1, since it is natural number, it should start with positive 1. Okay? So if we choose x as 1, then y is equal to 1 plus 5, 6. If we choose x as 2, 2 plus 5, 7. If we choose x as 3, 3 plus 5, 8. We cannot choose more than that, that is as it is given as x less than 4. Now we'll move on to the relation one by one. So first for reflexive, if we choose 1 from the set A, we should have 1 comma 1 in the relation. Do we have here 1 comma 1? No, it does not belongs to the relation. Therefore, R is not reflexive. Then symmetric. So if we choose a ordered pair 1 comma 6, say for example, then we should have 6 comma 1. Do we have in the relation? No. So but 6 comma 1 does not belongs to R. Therefore R is not symmetric. Then transitive, usually A comma B and B comma C. Yeah. So we cannot pick, B should be common, but if I take 1 comma 6, I don't have any other ordered pair with x as 6, isn't it? So here we cannot select B comma C as it does not belongs to R. Therefore, R is not transitive. So here also the relation is neither reflexive nor symmetric nor transitive. We'll move on to the next subdivision. Relation R in the set A is 1 to 6, as R is x comma y such that y is divisible by x. As usual, we'll write first of all the ordered pairs. So 1, it is like divisible by any number, isn't it? So 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6. Same way, for 2 we can say 2 comma 2, 2 comma 4, 2 comma 6. For 3 we can say 3 comma 3, 3 comma 6. For 4 we can say 4 comma 4, but any other number we don't have as a perfect divisible by 4. Then for 5 it is 5 comma 5, and for 6 it is 6 comma 6. So these are the possible elements. Now for reflexive, as I already told, we have to write the definition. So if an element belongs to the set A, then A comma A belongs to the relation R. If I choose here, we'll choose 2 belongs to the set A. Do we have 2 comma 2 belongs to R? Yes. So 2 comma 2 belongs to R. Therefore, R is reflexive. Then symmetric, if A comma B belongs to R, then B comma A should also belongs to R. So we'll take 2 comma 4. So here 2 comma 4, because 4 is divisible by 2, belongs to R. So can we say 4 comma 2 belongs to R? No, because 2 is not divisible by 4, isn't it? We'll get as a fractional decimal, but not an exact divisor. Yeah? So it does not belong to R. Therefore, R is not symmetric. Next for transitive, if A comma B, sorry, A comma B, B comma C belongs to R, then we should have A comma C belongs to R. For all A comma B comma C belongs to the set A. So that also I have forgot to mention here. For all the elements A comma B belongs to set A, here we have mentioned A belongs to A. isn't it? So here we'll choose in that way. We'll choose 3 comma 6. So here 3 comma 6 belongs to R, 6 comma 6 belongs to R. Then, so the 6 is common, isn't it? When we choose 3 comma 6, yes, that is also belongs to R. So then 3 comma 6 also belongs to this relation R. So therefore R is transitive. Finally, when concluding, R is reflexive and transitive but not symmetric. I hope it will be clear. If you have any doubt, comment in the post it in the comment section. We'll move on to the next subdivision. Relation R in the set Z of all the integers R is equal to x comma y such that x minus y is an integer. So here any number is possible because all the numbers are like integers, isn't it? We'll start with this. This will be an example for infinite set. We can write minus 1 comma minus 1 because minus of minus it will be plus. 0 is also an integer. So 0 comma 1, 1 comma 1, 1 comma 2, etc. So these are the possible ordered pairs. And next we have the reflexive relation, as we have if A belongs to the set A, then A comma A belongs to R. Isn't it? Here we'll take minus 1 belongs to the set A. So minus 1 minus of minus 1, that will be equal to 0. So 0 is an integer. Therefore, minus 1 comma minus 1 belongs to R. Therefore, R is reflexive. The next is symmetric. If A comma B belongs to R, then we should have B comma A also belongs to R, isn't it? If we choose two numbers such a way that it will be true, we will choose 2 comma 4 belongs to R. The reason 2 minus 4 minus 2, that is an integer, so that is true here. If we take 4 comma 2, so 4 minus 2, that is plus 2, it is also an integer. Therefore, R is symmetric. Then for transitive, the definition is if A comma B and B comma C belongs to R, then A comma C belongs to R. So we'll choose the pairs in such a way. We'll say for example we can choose 3 comma 4 belongs to R. The reason 3 minus 4 is minus 1 is an integer. 4 comma 7 belongs to R. The reason 4 minus 7 is minus 3, it is also an integer. Then we should say 3 comma 7 belongs to R. So 3 minus 7 is minus 4, again it is an integer, belongs to R. Therefore R is transitive. Therefore R is an equivalence relation because R is reflexive, symmetric as well as transitive. I hope it will be clear. So we should continue with the other sums in the next video. If you have any doubts, post it in the comment section. Thank you.